Okay. All right, I see Shauna, Grace, Eileen, Minjong, Eugene, and maybe Sumi. Who's recording today? Is it Sumi?
I think she's recording it.
Oh, okay. All right. Good. Okay. I well, I know some of you have classes. Eileen, do you want to go first? I know you have classes.
I can't go to class. I'm currently quarantined right now, so I will be able to stay.
Okay. Are you okay? I know you.
Yeah, I'm okay. Yeah, just like very, very mild symptoms, which is good. Yeah.
Oh, good. Okay, but you're better.
Yeah, for sure.
Good.
Yeah. So I get to get tested tomorrow, so I think I should be fine. Yeah.
Okay. Maybe we can do Minjung first because she's in Korea. Minjung, are you able to go first?
Yep, I'll turn on, I'll share my screen. So I'll give, wait, can everybody see the screen?
Yeah.
Okay. I'll give a brief update. I think I've shared most of it by email already, but this
So,
is
just for those of you who are not familiar with this project, what Minjung's doing is she gathered all the main articles on hyperprogression. When you get immunotherapy, some tumors actually grow faster. And how do you measure that? They use all different definition. So she classified different definitions and gathered data so that they could be all pulled for meta-analysis. I think she made some more updates based on some information she got. Okay, you can go.
so let me pull up one more paper, sorry. So this was the paper that the manuscript we're working on is originally based on. This publication is from last year, where they pulled all of the data from the literature they could find and just did a force plot of the overall incidence of hyperprogression that's found in literature. And at the time, what they did was...
Are you showing the Excel file?
No. Right now I'm showing the way the original paper categorized the definitions.
Are you showing the paper?
Oh wait, is there a PDF on the screen?
No, it's still the Google sheet.
Oh, I see. Oh, wait, let me unshare or reshare, sorry.
Yeah, now I can see.
Okay, yeah. So in this paper, they decided to examine the different kinds of definitions of hyperprogression. And they categorize the definitions in this way. And this is the categorization that I followed initially. But what I realized was that this publication here went on to mathematically model the different kinds of definitions. And I couldn't quite understand the math when I first read it, but when I read it recently, I realized that if you look at this graph, basically, the incidence of hyperprogression defined by each definition, which is labeled in one of the alphabets, is equivalent to the area above the lines. So if you look at A would define everything above this line as hyperprogression. D, everything above this line as hyperprogression. And so you can tell that each of the definitions describes a very different proportion. So what this means is if we look at they looked at the exact same population of patients.
So can you explain x-axis and y-axis? I need to understand.
Oh, I see. So if you look here, on the x-axis, it says S, and which basically means size. So the ratio of the size at baseline over the pre-baseline image plotted against the y-axis is the size post-baseline over the baseline. So when you when you evaluate patients for hyperprogression, you need 3 images. The one before the patient started immunotherapy, the one at around the time point when the patient started immunotherapy, and one image afterwards, after they started immunotherapy. The first definition here in its A was defined by a group called, the PI, his name is Ferte. What they said was, if the patient has a 20% increase in the tumor size after starting immunotherapy, which is equivalent to progressive disease, and they have a 2-fold increase in the growth rate, then it's defined as hyperprogression. And that's what it's showing here.
And is that the most commonly accepted?
It is.
Yeah.
So if you look at this line, the slope, it's 40 here and 20 here. So you can see that the slope is 2, right?
Yeah.
Because it's 40 difference in y and 20 difference in x. So this represents a slope of 2. And this 2 is equivalent to the tumor growth rate ratio that they describe. So let me first go back really quickly to the definitions here. Champion et al., who describes it as resist progression, and this ratio of tumor growth rate is greater than 2.
Is that a French group? Is that?
Yes, it is. 3 of the groups listed here are all French. The second group, this is the group with Professor Kurzrock. Instead of using progression, they used a clinical criteria. So RESIST is a radiological criteria where you look at the image and see if there's a 20% increase, then it's defined as progression. But the thing with hyperprogression is that it's not just clinical. It's not just radiological, there's also clinical deterioration. So instead of progression, they used a criteria of TTF, which is equivalent to time till treatment failure. And so they included this criteria instead and said, instead of a 20% size increase, which we call progression, we want a 50%, more than a 50% increase in the size and a progression pace increase in more than 2-fold, which is kind of similar to this TGR here. But the reason why they called it progression pace, which kind of sounds vague, is that they used a different evaluation criteria. It's called, so usually we use RESIST, but the criteria that they used here is called IRRC, which is immune-related response criteria. And the reason why it's different from RESIST is that this is unidimensional, but IRRC is bidimensional. So when you do the calculations, it's not equivalent to tumor growth rate ratio described here. Around the same time that Kato et al. Or Kurzrock's group presented this definition, Sadabuzir et al. Also presented a different definition of hyperprogression, where here it's defined as a tumor growth kinetics. So before I continue with describing this, you might be confused by the TGR, progression pace, TGK. These are all mathematical parameters that are used to describe the tumor growth rate. They just used different names because TGR is based on a volumetric model and TGK is based on a linear growth model. So TGR assumes an exponential growth in the tumor, whereas TGK is not describing an exponential growth, but rather a linear growth. And the main difference between these two is that this one didn't include resist progression as a criteria. And as a result, it can overestimate hyperprogression disease incidence. A few months later, Singhavia et al. Presented this definition, which uses the progression part, just like Champiat, but then it follows Kato et al. By using a resist increase of more than 50%. And it also uses Champiat et al.'s tumor growth rate ratio of greater than 2. And then lastly, Ferrara et al., which is by the Caramella group, took a kind of different approach. And instead of taking the ratio, they decided to do the absolute difference in the tumor growth rate after starting immunotherapy and at the time when the patient first, at the time before they began immunotherapy. So this
So
is
it's
the,
minus?
pardon?
Is it my TGR EXP minus?
Yes, it's the absolute difference. So TGR is described, it's when you calculate it, it's a percentage. So let's say the tumor growth rate was calculated to be 200% once the patient started immunotherapy, and it was 100% before, then you do 200% minus 100%. And if it's greater than 50, then it's defined as hyperprogression. And now that I've kind of poorly described,
Progression pace. How do you calculate progression pace?
let me, let's see, wait. Could you give me, no, never mind. I don't want to show my notebook because it's too messy, but here, I'll pull up another paper. So this is Champiat et al.'s paper by the Herte group. And this is the mathematical portion of their paper. So this is the part where they model the growth to be exponential. So this is the basic formula for an exponential growth model. And what they do is when we think of volume, we have to kind of generalize the shape. So they went on with the shape of a sphere, which is 4 pi r cubed divided by 3, where r is equivalent to the radius of the sphere. And so they calculated the radius by taking the diameter, which is the tumor size measured by RESIST, and they divided it by 2. And from here, they did a mathematical transformation, and they used the log scale calibration so that the tumor growth rate that you see here is basically equivalent to 3 times the natural log of the ratio of the diameter after and before, divided by the time. And in order to make the calculations more convenient, they converted it to a percentage. And so you take the diameter measured on the CT scan, and you plug it into this equation here, where the tumor growth is equivalent to this equation here, 3 times the natural log of the ratio of the diameters over time.
Hmm.
And so this is how Champion et al. Described tumor growth,
Uh-huh.
which it intuitively makes sense because we expect the tumor to grow exponentially and not linearly.
Right.
Sadar Bouzid et al. Took a different approach because the reason why they presented this definition was that they said the calculations might be too complex for TGR. But the nice thing about TGR is that Champion's group basically shared a script with the public where people only had to enter the sizes before and after, and the script would do the calculations for you.
Hmm.
It's actually not very difficult, and I think it's very accessible. But just to present how Sadar Bouzid et al. Describes their definition, they went with a simpler mathematical calculation, something that any of us could easily calculate with a pen and paper.
Uh-huh.
So they just literally took the sizes. So this, you can disregard all of these little subscripts, which makes it complicated. You can just think of it as a difference in size over time. So they took, pardon?
One dimension.
Yes, one-dimensional. Difference in size over time before immunotherapy is described as TGK pre, and the difference in size over time after starting immunotherapy is described as TGK post. And you take the ratio of TGK post over TGK pre, and if it's greater than 2, greater than or equal to 2, then they defined it as hyperprogression.
So that the sum of, but the size is defined by RECIST.
Yes,
Yeah.
yes. But the Kurzrock group used IRRC, which is quite different. And I'll describe why that became problematic later when I categorize the definitions. So I'll go back to Kato et al. So what they did was, first, they mathematically modeled how if you had the same population, what kind of differences would we observe in the hyperprogressive disease incidence? And you can see from this graph that the areas that are covered by each definition are clearly different. A and D might seem similar because they have the same slope, and this is because they depend on a TGR ratio of greater than 2. But D has a criteria where instead of progressive disease, you need a size growth that is greater than 50%. So this area that you see here would be different for A and D. And depending on the sample size, you can't ignore the difference. And for definition C, for example, because this is the definition by Sadar Bouzid et al., because it doesn't include progressive disease, there's this much that isn't covered, which is eliminated by other definitions. And E here is the definition where you take the absolute difference in the ratio. So after taking this apart, sorry.
Difference. So the slope is 1, but there's y-axis difference of 50%.
Right, right.
But is that how it's? But it's not 50%.
What isn't 50%?
So absolute difference of 50%. So I was thinking the y-axis should cross at 50%. Isn't?
Should. Oh, I'm so sorry. That's D. You're right. You're right. This is D.
Oh, D is the 50%. Okay.
Right, right. Wait, I am so sorry. E is, I think it's, D is Singabi, where it's 50% increase. Wait, E is for varicella. E required a 20% progressive disease and a TGR absolute ratio of 50%. So this part is not a ratio, but it's the absolute difference.
But the slope looks like 1. No, is it not 1? Let me.
I believe it is 1.
And why does it stop at 20%? Huh.
Why does it stop?
What the E graph stops? Why does it?
So if you look at A and E,
Uh-huh.
any patient who doesn't have progressive disease,
Uh-huh.
which corresponds to this line here, isn't considered hyperprogressive disease. So A and E exclude anybody who is below this line.
Oh, so A and E. So actually, there's a gray dot going to
Right.
20%. Okay. But that,
Right.
yeah, that wasn't clear to me.
Mhm.
And
So the only definition that doesn't consider progressive disease is this definition here, which goes all the way down to 0. If you look at the y-axis, you can basically think of it as the ratio or the change in the size after starting immunotherapy.
Mhm.
And 20% corresponds to the RECIST criteria of progressive disease.
yeah. Now I'm trying to understand the graph E. I can understand the slope is 1, but
Mhm.
I'm trying to think whether that 50% should be reflected in this graph. E,
Mhm.
shouldn't the E cross at y-axis of 50%?
Oh, I see what you mean. But then that, because, okay.
Because you said the absolute difference of 50%.
Right. It's the absolute difference in the tumor growth rate, whereas this axis here
Uh-huh. Is not tumor
represents the tumor size. It's the ratio of the tumor size here, and not the tumor
Yeah.
growth.
growth rate is the exponential.
Right.
Okay, so that's why it's not okay. So exponential, so if it follows growth rate, E and A is the growth rate has linear slope versus C, which uses the TGK, is actually not linear.
Right.
That's interesting.
So they describe in the paper how if you use this definition of C, it will definitely overestimate when the patient basically beyond this line,
Yeah.
it will estimate far more than definition E. But interestingly, if the patient has a ratio before starting immunotherapy that
Uh-huh.
corresponds to 20 to 90%
Uh-huh.
ish, it will underestimate compared to E.
Hmm.
And so what they did afterwards
Uh-huh.
was this group, when they initially presented their paper on hyperprogressive disease, it was based on a cohort of non-small cell lung cancer patients. And so they went ahead and applied this definition to calculate what the incidence would be according to each definition,
Hmm.
which is presented here. So you can see that each definition calculates a very different incidence.
with all, yeah, say in the same population, huh?
Exactly. So out of a total of 406 patients, this is the definition that they used, which gave them a incidence rate of 13.8, which seems similar to A here,
Yeah.
but definition B, which is Dr. Kurzrock's group, is definitely lower.
Uh-huh.
Whereas the Sada Buzira, which I shared, doesn't include progressive disease as a criterion, definitely seems to overestimate
Hmm.
the incidence. And more surprisingly, what they talked about was, for example, if you look at A, it's 12.8. And what's similar to this would be definition E here, right? Because 12.8 compared to 5.4 versus 18.5 versus 6.2 versus 13.8. So initially you would think, oh, I guess A and E then basically are similar definitions and can be interchangeable. But what they did next was, this is called the Jacquard index value. And what it does is it checks the concordance. What that means is, for example, they took the group here, the 52 here, and the 56 here, and tried to see how many of them were matching, were the exact identical patients. So yes, definition A spotted 52 people, and definition E spotted 56 people, but how similar are the 52 here and the 56 here? And so if you look at this value here, definition A compared to definition E, you see that only 44 patients were the same.
Hmm.
And this was equivalent to a concordance rate of 68.8. So the important point that they made in this paper was, even if these a set of two definitions may seem to describe similar hyperprogressive disease patients, each of these definitions with the highest concordance of only 69.3 are actually describing a different tumor behavior and are capturing different kinds of patients. And so they concluded in the paper that this is the reason why the definitions need to become more uniform. Because even if we previously thought we were calculating a similar incidence, we're actually grouping different people. And we need to figure out what is the best definition.
So what is your interpretation? I know the surface interpretation you just said.
Mhm.
With the, well, I guess the question is, what definition to you makes more sense clinically, or you don't know?
Even though I haven't studied hyperprogressive disease long enough, I definitely would think that definition C is overestimating because it is not including progressive disease.
Mhm.
And that's why some groups have actually included progressive disease in addition to the TGK ratio that Sarabuzir et al. Used.
Hmm.
So if I'm gonna now show the definitions that are in the paper, and you'll be able to see how people tried to improve on these previous definitions by including different criteria.
Okay, before you do that, I
Uh-huh.
need to help me understand that graph one more time, because in
Okay.
my mind, I'm still struggling mathematically. Somebody good at math help me here. So if you TGK and
Uh-huh.
TR, let's look at the difference one more time.
Oh wait, the
Go to the
definition.
initial math equation for TGR and TGK.
Okay.
So everyone remember x-axis and y-axis. It's just the size different, it's the ratio. And here TG is defined exponentially, so it's the log. And if you compare the the size ratio, just the size ratio, you have TG, which is the log from the DT divided by D0, and D is just the diameter. On treat is it, well, I guess 2 time points between the 2 time points.
Mhm.
So TGR is an exponential graph that
Mhm.
touches when TZ is, if the growth rate is 0, it doesn't grow, then it can't be 0. Well, so wait, TG, that's the TGR.
Mhm. So I guess
Hyperprogression is divided by TGR before and after treatment greater than 2, right?
right.
So that definition, and if you can you go back to that graph?
Oh, I think I'm understanding where your confusion is coming
Trying to understand how, because there's no logarithmic scale here,
Right.
and
Okay,
its
yeah.
x-axis is just the ratio, baseline, pre-baseline. Y-axis is the new treatment size and treatment baseline.
Mhm.
I need to understand why A is still linear here.
I see. Let me go back to this, the Champion et al. So if you look at the tumor growth rate, as I said before, it's a log, natural log calibrated growth rate. But then if the way they what is it, presented their definition of tumor growth rate, it's the exponential of the tumor growth, right? Which is this value here. When you take the exponential of a natural log, it disappears. So it becomes linear.
So this TGR is just like how they defined it.
So I can wait. Let me bring my notebook really quickly.
Because TG is derived from their tumor growth. So tumor growth rate is this divided by, is log divided by log, or
So let's see.
you want to write on a
Let
paper?
me- Yep. I'll.
It's been it's been a while. I've been exposed to mathematics.
It was the same for me. I didn't understand what was going on at first. So let me just pull up my notebook. Okay. Let me. I don't know how well this will work, but
Are you on like a memo?
yeah, it's okay. It will be really messy, so I'm really sorry if this doesn't help, but
Yeah, we can see it if you get it close.
I don't know how to. Oh boy, this is literally my. Okay, so
Oh yeah, we can see it. We can see it. Yeah.
if you look at, oh boy, this here,
Yeah.
this is basically the equation for exponential growth,
Uh-huh.
where you have the volume
Mhm.
at a time point t is equivalent to the time to the volume at time 0 multiplied by the exponential of the growth rate.
Yeah.
And then they went on to transform this to get the tumor growth rate, which is here. It's exponential of the tumor growth rate times time as the exponent. So they isolated the tumor growth rate here. And if you follow this transformation, which, yeah, it's okay, you don't have to follow it. You get this equation here,
Yeah. We can follow
which
it.
is the log,
Yeah.
and then it's the ratio of the volumes or the size
Yeah.
over time.
Yeah. There we got it.
And then what they did was, when they defined the tumor growth rate,
Mm-hmm.
they said the tumor growth rate is equivalent to the change in the volume,
Uh-huh.
which is the volume at time t minus the volume initial divided by the volume at time 0.
Mm-hmm.
And let's express this as a percentage. So they multiplied it by 100.
I see.
And into the formula for volume at time t, they plugged in
Mm.
the exponential model.
Yeah, makes sense.
And then when you cross out, when you clean things up, you get this equation here, which I showed before.
I see.
And the last part is, if you plug in this portion here,
Uh-huh.
which is the log, if natural log, if you have an e and a natural log, it cancels.
Uh-huh.
And that's why the calculation that you get is no longer, it's no longer a log scale. It goes back to a linear scale, just of tumor growth. And that's why on the graph it's linear. But this
Yeah,
is
I didn't get the last part. So,
let me
that was the last equation was TGR itself.
right. It's
And then you want TGR pre and post ratio, right?
right. So what you would do is
So ETG 1 T minus 1 divided by ETG 0 T minus 1.
let me try to
Is it frozen or?
no, sorry. I'll here, I'm gonna change my screen one more time. Sorry.
Sorry guys, I need to understand mathematics first.
I'm sorry. I'm
Like
just
that graph, I mean, it's a really good paper. I mean, I could see this type of paper could be done with any hypothetical, model, and you can try different definitions.
wait, is my screen showing? No, right?
No.
Okay. I'm going to share my screen. Okay, my screen is showing, right? Yeah, I was never strong in math. So I think that's why I'm not describing this well, but I will give an attempt. So
Are you using mouse to do this?
No, it's a the like the
Tablet?
drawing. It's a drawing
Okay.
tablet.
Nice.
Yeah. But so excuse my. It's not going to be neat. So we have a tumor growth rate, which is described.
Yeah. Yeah, that I understand.
So we have that. And then now when we describe the ratio, we call it, they usually use EXP for when the patient is receiving therapy.
Hmm.
You compare the growth rate when the patient is receiving therapy versus, they call it ref, which is before.
Before, yeah.
So if we do that, then it would be oh boy. The tumor growth rate, I'm just going to use EXP times the TEXP minus 1. So I'm just using this equation.
Right, right, right.
And you do the same. Okay,
Right.
I'm going to save time. Then what you would get is E of, sorry. Of 3, the tumor growth rate we found was 3 log. No, let me not use log. Because log it's different. Oh, this is messy.
Yeah, so it cancels out.
Right, it cancels
Log
out. So it's
cancels out.
right. So it's no longer log calibrated. So this cancels out. This cancels out.
In the
This,
log.
this cancels out. And the way this works is, since this cancels out, you can bring it out to the front. So it cancels out like this. The dt over d0 is actually different for this one and this one, but since I'm not good at writing with this tablet.
It's 3 different time points.
Right. So this T0 here is after immunotherapy. This here is when starting immunotherapy.
Right,
This T here is when you're starting immunotherapy.
right.
And this T here is before.
Yeah.
But since E3 is a constant, you basically get a numerical value that's not related to the log.
So E3 is constant. So this is really, there's -1. So this equation is TGR ratio.
Right.
Is it TGR ratio?
And basically what they did was, so they defined it as Champia described it as TGR ratio of 2 or greater, right?
Yeah.
So the way that graph is modeled in the paper is they rearranged this equation. So when I showed the y and the x-axis, this part corresponded to after immunotherapy, which corresponds to this ratio here.
Mhm.
So they rearranged the formula so that this is equal to, and they rearranged it. So it would be the same as, I didn't do this calculation before, but
Yeah.
yeah, it would be blah, 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 blah.
Yeah.
But you can see this 2, which is what we observe in the slope. It would be that plus 1.
Yeah. Now I get it.
So it's, yeah, it's no longer
Yeah.
that's, the graph doesn't reflect a log.
So y equals 2x plus 1 over e3. So it's the slope is 2 and the y-axis is 1 over e3.
I haven't gone through this part myself, but I can try
This
to clarify it.
perfectly describes the graph, and because this is only possible when using the exponential model as a TGR,
Mhm.
K is only gonna go less than the linear slope here. I can see that happening. And that's why the slope, yeah, that's why the y-axis for TGK is going to be different. Okay. It's interesting. So that's TGR. Hmm. Hmm. Okay. So I think when you define TGR as the volume ratio and the TG was defined exponentially,
Mhm.
I think it, I think that's why we see this linear pattern here. But okay.
I'll try to do the remainder of the calculations. I think I might lead more people to confusion by trying right now, but since they depend on a criterion of progressive disease,
Mhm.
that would mean that they define, wait, so not here. That would mean that this would have to be equivalent to, no, actually, no, I don't want to assume anything, but I'll try the math. But I just tried to get an approximate understanding of what this graph meant,
Mhm. Mhm.
which I didn't understand when I first read this paper.
Mm.
But if you look at the post baseline versus the baseline, this 20% is corresponding to progressive disease. Because RESIST defines progressive disease as a 20% increase in tumor size.
Mm.
Whereas definition D, which is the definition by Singavi, they say progressive disease at 20% is not enough to define people who have hyperprogressive disease. You need somebody who has at least a 50% increase in the tumor size.
Mm. Mm.
So instead of this definition of A before, they modified it with a higher threshold.
Mm.
And so these two can be described as being similar, but this portion here is still not being accounted for.
Mm. Mm.
And so I didn't realize how drastic this difference was at first. And that's why I'll now go to,
Okay, let me give you one insight. So for all of you, the reason why this looks very complicated is because of the resist. In an ideal world, the best way to always measure tumor is by volume. But
right,
for convenience, we were always going by the what's the largest diameter. Let's just add them up together, which is not an exact, you know, and that's the seed of all confusion, because the definition by group like A and B, the core definition is the volume ratio. But then you have the mixed resist definition here for practical reasons, because people want to just be very simple, you know, let me just add up the sum of the largest diameter. And that's how we were defining progression, which I think it's a major flaw. And we're just trying to incorporate that because of that practical reason. And that's why we're now having this complicated definitions. In a real, in an ideal world, the one and only true definition should be the volume. And you could see when the tumor grows, 1 centimeter to 2 centimeter growth, that time, the time to take 1 centimeter tumor to 2 centimeter tumor by the largest diameter is very different from 15 centimeter to 16 centimeter. You feel like the tumor is exploding in the end. People go to hospice in the last 1 month. They deteriorate really fast because, you know, the tumor grows exponentially. And the time it takes for 1 centimeter tumor gets to 2 centimeter could be the same as 10 centimeter tumor getting to 20 centimeter tumor. And the volume is, you know, the to the third of the diameter. So it's huge. So for tumor to suck up your nutrition to maintain that growth, you're gonna be all bones. And really, you know, you so what I'm trying to say is, you know, the volumetric should be the ideal form, but we're incorporating resist here, and all this 20%, 50% is based on the one dimension. So that's why there's such confusion and difference in measuring kinetics. So Minjung, what is your opinion about TG R versus TGK?
So without the criteria of progressive disease, the TGK definition is definitely estimating a higher incidence, but I'll show one paper which is in our meta-analysis. So in this paper, they looked at 3 different definitions. And when they looked at TGK, they added the criterion of progressive disease, which was what people considered the limitation of Sada Bouzid et al.'s definition. And if you look at, wait, it's in the supplement. Let me.
Is this
Okay, let me pull up another paper that also.
St. Mary paper? Which is it?
Pardon?
Which hospital is this from?
This one was, I believe, Yonsei Hospital.
Yonsei? Okay.
Mm-hmm. let me try to find, there's another paper that's something similar. Oh, here it is. Okay. So here they actually used even a different threshold. Instead of a TGR ratio of 2, they used a TGR ratio of 4. But the point is to show that, oh no, it's not this paper, sorry. Oh, it's this one. So I showed the concordance. I explained the concordance before, right? If you look at the concordance between TGK ratio and progressive disease and TGR ratio and progressive disease, it's 95%. Can you see the numbers here?
Yeah. Let me see that.
So previously without the criterion of progressive disease,
Mm-hmm.
when you look at Kos's paper, so when you compare C and A,
Uh-huh.
there's only 69.3% concordance. And this is because in this case, the TGK ratio doesn't have progressive disease as a criteria.
I see.
But then when different authors looked at TGK with the progressive disease criteria, it was actually pretty similar to the TGR ratio.
So remind me the TGK equation one more time.
The TGK equation is simply taking the size difference over time and taking the ratios of the two.
Just the size different, not the volume. So it's like the resist ratio.
Mhm.
Same thing as resist ratio.
Right, right.
So can you go back to that XY axis graph
Mhm.
one last time?
Right, of course.
So if you look at the graph C,
Mhm.
let's see, extreme end, let's say 150. So
Mhm.
the baseline ratio, the size ratio is 150%.
Which means that even before starting immunotherapy, the tumor was growing at a fast rate.
Right. But then it's 120
Mhm.
on immunotherapy. So it's actually growing less. But what's above C is defined as hyperprogression,
Mhm, mhm.
which to me doesn't make sense. I mean,
Let me. So
because it's the size ratio of 2 or more, right?
mhm.
Because when the x-axis become the value becomes larger, then you overestimate.
Mhm.
Um, but how do you explain that it's the rate? I mean, yeah, this graph is not easy.
It definitely isn't. But like, for example, we can just look at, okay, I think another way to think of this is, first of all, this is a typo, but this should be 120. So let's say that a patient was having a tumor growth rate prior to immunotherapy of 120%. And then when we looked at the ratio after receiving immunotherapy, and it was 110. According to Sada Bouzid et al.'s paper, this patient would be considered hyperprogressive. But according to definition E, this person lies below the line E. So that patient wouldn't be considered as having hyperprogressive disease. Because the proportion of people who have hyperprogressive disease is represented by the area above this line. Let's say we have a patient who basically had a tumor that wasn't growing at all prior to immunotherapy. And then that patient, after receiving immunotherapy, had a 20% increase in size. Then it would correspond to this point here. According to the definition by Champia et al., this patient would not be considered as having hyperprogressive disease, because this point lies below this line here. And everything in this region would be considered hyperprogressive disease.
Yeah.
So according to,
One more thing. Now I see that, like before you start the immunotherapy, let's say you have a CT scan at biopsy and you have a CT scan right before you start the treatment. So usually the tumor does not shrink on its own.
Right.
Practically, it has to be 100 and above on the y-axis, practically speaking. So what's left side of the x value of 100 doesn't really mean much clinically. Does that make sense? Or is this a delta increase in percent? Like, is it? Do you understand what I mean? Is it?
Right. I think one way to think of it is that some of these patients, they didn't start immunotherapy immediately after experiencing progression on their prior therapy. So if they had progression and they started immunotherapy soon afterwards, then I think we would be only interested in this area here. But I think in reality, sometimes there was a time gap between the time the person stopped the prior therapy and then started immunotherapy. And so in some cases, I think there were people who basically didn't really show that much tumor growth.
So x-axis is really the dt over d0, meaning it's really the size ratio. It's really the size ratio, not the delta size, right?
But it definitely, yeah, it's not delta for sure, from what I understood.
But it looks like it's delta on the y-axis because you're talking about 20% difference here. I think it's delta and 20 and 50% y-axis.
I actually, now that I look at it, I think instead of delta, it's let's see.
Can you look at the methods? That's why this graph is confusing.
I think it's, let me figure.
in S baseline, S pre-baseline. What does S mean?
S refers to size.
Size?
Yes. Let's see. Tumor burden at pre-baseline, post-baseline will be termed as pre-baseline, as baseline, as post-baseline. So it refers to the size.
Size?
Mhm. So instead of, okay, I think I understand what you mean. But instead of delta, I think it's S post baseline minus S baseline over S baseline because it says percentage here.
Right.
So it's not the absolute difference, but it's the change in the percentage.
So it is delta if you think about the 20%, right?
Delta as in,
So
so
y, if you
when, Mhm, mhm,
go at the y-axis, this 20% means
mhm.
change in the largest sum of size that resist. Just think about resist sum,
Right, right.
and there's a 20% increase in size. Increase.
Mhm.
So instead of having a line at 120%, it
Mhm.
has a line in 20%. So to me, y-axis is talking about delta.
Oh, I see what you mean.
Because if you just go by the absolute number ratio, size ratio, it has to be 120.
Right, 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 right.
So either they should draw a line at 120 if they really meant x-axis to be the not delta. Do you understand? So I
Right,
think
right, right. I don't think they were consistent. Right, right, right.
I think it's author's error here. Now I'm convinced.
Right. I didn't think of that at all. Yeah, I'm sorry.
No, it's author's fault. It's not your fault. I think it's a major flaw. So if we go by the equation that you showed, y equals 2x plus 1 over e3, that is the linear graph that you see number A.
Right, right.
And I think it's it should not cross 0. It should cross 1 over e3 to be exact. And then I think it should, and then the x-axis is really it's not delta. X and y is really the ratio of the size. So you should have this horizontal graph that is at 120 and 150. That is my interpretation.
Right, right, right. I think they mislabeled
Yeah,
here.
yeah. Now
Right.
See, these reviewers didn't pick it up. I'm pretty convinced that this is so schematic. I don't think they meant it mathematically. I think they were just still trying to be schematic.
I'll try to make a plot.
Yeah, try to make a plot mathematically. Like the calculators or the programs, you can draw a graph based on actual mathematic equation and really put resist criteria of 20%, 50% in the graph, and you will have a different graph. So my suggestion is, why don't you actually draw those graphs yourself and make a graph, and we can put that in our meta-analysis, the model, and also send that graph to the corresponding and first author here let's see what they say. We think this is the accurate mathematical representation here. I think you guys drew the line in the wrong place.
I mean, I personally, may I make one
Yeah,
suggestion?
yeah, yeah.
I personally think that the only thing that needs to change
Uh-huh.
here is, so, okay, let me try it. Oh no, it's too
Mm.
small. Oh wait, let me just, okay. So I think the only thing that's problematic here is this designation here. So if you have, so they have 20 marked here, right?
Yeah.
I'm just gonna use X for size. Let's say X2 is equal to 120 and X1 equals 100. Then we get 20%, which corresponds to progressive disease, right?
Mm-hmm.
So I think what they meant here is this. Then this y-axis makes sense.
Mm. What about the x-axis? Should be the same thing.
It is. I think that this designation here is because this actually happened in another review paper where they just used the slash and it actually didn't mean the ratio. I think they're just saying comparing the baseline size and the pre-baseline size. And that comparison mathematically, I think, is equivalent to this here.
So it is delta. It is delta.
I think the reason why I was confused by the designation delta is that when Ferrara used delta, it just means the absolute difference between the two ratios. But yeah, I understand what you mean by delta. It's the, yeah, it's the slope in the change.
So then go back to the initial definition of TG. When TGR, go back to that reference paper, TGR.
Mhm.
Okay, so look at here. TG equals 3 log dt over
Mhm.
d0. So is dt actual measurement or is it delta?
It's an actual measurement.
It's an actual measurement.
Mhm.
Because because this is actually, if it increased by more than 2, it's the 2. It's not that, I mean, that's the only way it makes sense. It's the actual measurement.
Mhm. I'll try to work on the math and present it next week.
So I think actual measurement makes sense. I think that's more exact, and I think here it became it's clearly delta actual measurement ratio. So I think they just moved by 1. I think that's what happened. They just made it change by 1 to make it delta, because it is ratio.
Mhm. Yeah, I can see why you're saying this graph is problematic. Oh,
So the actual graph, but anyway, the graph does, whether it's delta, the
Mhm.
graph does not cross 0.
mhm.
It might not, it just may not, the A. Yeah, let me, if you look at my screen, if you unshare, I can show you my equation here.
Mhm.
So y is the actual, I see it. The y is the, is it upside, is it,
It's right.
it's right for you? Okay. So y, this is assuming that it's the actual size ratio, dt minus dt over d0, and
Mhm.
it's y equals 2x, and the y-intercept is the e3, 1 over e3.
Mhm.
But then if you do the delta, it just moves by 1. Y minus 1 is the delta, because y is the ratio, 1 is 100%, right? So I think what they actually drew is the y minus 1 here.
Mm.
So your y-intercept changes, the slope remains the same. But anyway, I think, yeah, I think they should change that to delta ratio, that delta ratio.
Mhm.
And they should have been more accurate in terms of the y-intercept.
Mhm.
Okay. But I think we can still send the others that, well, I think it's so obvious that maybe, but my suggestion is with the different, with all different definitions, actually draw the plot
Mhm.
and see how different it is. And I think you can draw the plot and put that in our manuscript, because it's sort of like a mini review too,
Mhm.
to show people how different the definition is. I think it's a good representation, and we could be more exact by showing it's the delta, and the actual mathematical representation shows, this, and you can actually color it differently, how, where the discordant population is, and I think it will be nice because you've gone through all this mathematical exercise.
I'm not sure if I'm mathematically competent enough, but I'll give it a try. I'll give it-
You can do it. Yeah. Okay. Okay. Show me our paper now, how you applied it.
So wait, am I sharing it? No. Um, so this initially, when I categorized the definitions, I did it according to what they did here.
Yep.
But I realized that this, there are too many variations. So as I mentioned before, because Sada Bouzid has the limitation of not including progressive disease,
Uh-huh.
some of these papers said, oh, we improved on the previous definition by adding the criterion of progressive disease.
Right.
But the problem is that makes it completely different.
Yeah.
At first, I didn't realize that. So I just grouped it according to the tumor growth parameter that they used.
Yeah.
And so I reorganized all of the definitions that are included in our paper. So this is the original source of the definition. And if you look at the right side, this represents studies that are based on that definition. First of all, you can group it as having one tumor kinetics parameter or having more than one. So
Uh-huh.
let's just look at one tumor kinetics parameter. Champia et al. Uses the tumor growth rate ratio. And these papers here use the exact same definition.
Yeah.
But if you look at the ones in green, basically, they've made changes. So Arasanz et al. Is not that different, but they use the IRRC criteria that Kato et al. Used. And Tunali et al. Added an additional criterion of time to treatment failure of less than 2 months.
Yep.
This one is mislabeled, but Lee et al. Also added a different criterion. Sarabuzir et al.'s definition, these papers were exactly the same, but these 4 papers were different. But in terms of the evaluation criteria differences, I don't think the differences will be major. I think the problem is when they add additional criterions like progressive disease or time to treatment failure of less than 2 months.
Yes.
The most problematic one was the definition by the Kurzrock group, because as I mentioned before, they had an ambiguous term, progression pace.
Uh-huh.
So what the authors did was they just used whichever tumor kinetics parameter they were familiar with. So these two,
What did Kato use?
they basically, it's similar to TGK, but based on a bidimensional measurement.
TGK, but using IR.
RC, which, so RESIST basically takes one diameter from each tumor lesion, but IRRC takes the longest diameter and then the diameter perpendicular to that length. Does that make sense?
Do you add those two?
Right, you add the two.
Yeah.
So
That's the
this,
response criteria by WHO.
exactly, it's what they used to use before.
Yeah.
The problem is that you can see that they use the TGR ratio in these 2 papers. And this one added another criterion of new lesions. This one used a different threshold of a tumor burden increase of 200%. This one excluded the criterion of time to treatment failure and used the TGK ratio. And this one used a volumetric tumor burden increase. Kim et al., this paper here is a radiomics-based paper. And G et al. Is also a radiomics-based paper. And so you can see that of all of these criteria, for every definition that's in this category, none of the definitions were identical. And
Is Kim coming from Asan? Is that where's Kim?
this is the group at
연세?
Samsung.
Samsung. Okay.
And so after I realized how different these definitions are, oh, and then moving on to using more than one tumor kinetics parameter,
Yeah.
because these definitions were showing different groups, what some studies started to do was to combine different tumor kinetics ratios. So they looked at TGR ratio and TGK ratio of greater than 2. And they only took people who belonged to both groups. So they looked at people who were defined as hyperprogressive disease according to a TGR ratio of greater than 2. And then they re-looked at the population looking at a TGK ratio of greater than 2. And then they only took the people who were found identical in both groups, if that makes sense.
Yeah. I oppose to this. This is too strict.
But then as I showed before, if you add the criterion of progressive disease to the TGK ratio, it's pretty similar to the rate you get for PD and TGR ratio of greater than 2.
Yeah.
So I think it's less strict if you use TGR and TGK, but if you look at this next definition here, it's TGR ratio and delta TGR greater than 50%. And this one here is TGR and TGK and delta TGR. And I think this is the most strict you can be. But of all three, TGR, TGK, and delta TGR is usually the most narrow anyways.
Yeah.
So it's not very meaningful. You can basically think that they use this number.
Yeah.
So after I found out about this, I realized that I couldn't group these together anymore according to the category used by the previous authors. So what I did instead was I contacted all the authors in green. And
Why just green?
because these are the ones that are deviating from the original definition,
Oh, okay.
that modified the definition in their calculations.
Uh-huh.
And I explained that in terms of a meta-analysis, in order to do a rigorous comparison, that these definitions have to be identical.
Uh-huh.
And I requested if they could recalculate their data based on the original definition.
No definition. Yeah.
And I explained that I believe that these modifications that they used actually may better discriminate hyperprogressive disease. But just for the sake of doing multivariable analysis, in order to, because what happens is if I use their definition, it can result in what people call misclassification bias. And what I mean is, for example, I shared before that if you add the criterion of progressive disease to the TGK definition, it's actually now more similar to this group than this.
So that's what JAMA paper actually did, right?
Exactly. Oh, the JAMA paper didn't compare the definition of Sadabuzid with PD though.
But they didn't do definition to definition comparison.
Right.
I guess that's why they were more lenient. Okay.
They didn't they just categorized it, but they didn't do any analysis.
Okay.
So I've contacted these authors and they've thankfully, many of them have agreed to recalculate for us, or I was able to look at details inside the manuscript and find a calculation based on one of these three categories.
So what percentage got back to you with the data you can use?
I think out of 7 that I've contacted, 1 did not reply. 1 did not want to share the data. And for now, the rest agreed to send their data, and 3 of them have already sent their recalculations.
That's really good.
I'm really grateful that they responded. At first, it was a little bit difficult to get in touch, but
it's always difficult. Everyone's so busy.
right.
But,
and I also realized that the ones marked in red, that we have to exclude them. Even actually Cotto's paper. The reason being, when you calculate HPD incidence, what's important is that the number that you put in the total only includes patients who had all 3 images available. because in order to do a tumor kinetics parameter calculation, this is a requirement.
Right.
But the problem is, at first, I just assumed that that's what all of these papers did.
Uh-huh.
But later, when I relooked at the papers, I realized that some of them didn't do that. What they did was, according to RESIST, they found out people who had progressive disease,
Uh-huh.
and then they just counted that as the total. And then they looked at people who within progressive disease had 3 images. Does that make sense? I can show an example.
Yeah, so yeah, no, I understand. So
And so
so their N is more than 3 images. They included people with just 2 images,
right.
or yeah, or a pre-treatment baseline.
So what happened was, if it was unclear, I contacted the authors and asked them if they could share the correct number.
Huh?
And that's what Nakamoto et al. Did for us. And Matsu et al. Also did that for us. And this group here, I was really grateful because the professor went through all of the images again
Uh,
and found out the patients that didn't have 3 images. And he got back to me with the corrected total. So we were able to save some of the papers that way. And then Schwiveling et al., for example, they used a really strict criterion of more than 200% increase. But if you look at this graph,
yeah.
the triangle represents the definition by Champiat. And the purple square here is their definition. So they said there was only 1 patient with progressive disease. But this section overall here is equivalent to Champiat's. So I was able to calculate the incidence again that way. And so I'm in the process of waiting for data from 2 more groups. And afterwards, I'll be able to run the script one more time.
It's disappointing that Kato had inaccurate denominator.
Right. And I think it's understandable why this happened. It's because that group was one of the first ones to describe hyperprogressive disease.
Uh-huh.
And if you look at their paper, their total is not based on people who had images, but they sorted out people who had time to treatment failure less than 2 months.
Okay.
And then from there, they calculated the progression pace. But if you look at their supplemental data, it says that for some people, this pace couldn't be calculated. And that's because they didn't start with a total of patients who had all 3 images.
Right. So well, but what's their denominator? It should be all comers first.
It's just their denominator is everybody who received immunotherapy.
Everybody who received immunotherapy.
Right.
From then, you first screen for treatment failure less than 2 months, and then from that they calculated the tumor progression pace. And if that was greater than 2,
Right. And a tumor burden increase of greater than 50%.
okay.
But the problem with using the total cohort is that all of these other calculations, once you removed people who didn't have 3 images, the total was much smaller to begin with. So if I pull up let's see. So if you look at Kato, their percentage is very small. And I believe this is because they just consider the entire group of people who received immunotherapy as their overall number. But afterwards, all the other studies started to try to base their total on the number of people who had all three images. And so we can consider that their methods were similar in their calculations.
But
But
did
the
you
one,
ask Kato if they
pardon?
did you can ask Kato to see if they can give us number of patient who has 3 images.
I tried, but I haven't been able to receive a reply. Maybe I'll try again. But,
Yeah, just ask one more time.
okay.
Kato is a good friend of mine.
Right. He said hello last time.
Oh.
I think maybe it's because I've been sending too many emails. I understand.
So I just for all of you guys. So this is a growing field. This is a niche, and nobody knew anything about hyperprogression. And one group in France says, wait a minute, I'm giving immunotherapy and it looks like the tumor is exploding. What's going on? And then they created the term hyperprogression. And when Dr. Kurdrag at UCSD with Dr. Kato went to medical school in Tokyo. Anyway, he came to United States just like Eugene and Seungmi, and did research and became faculty at UCSD. Anyway, they both thought this may be real. I'm actually seeing in my clinic that tumor is exploding with immunotherapy, and what is the best way to determine or who's the progressor and what's the predictor, and that's a whole other story. But so all different these, and then for the first few years people said that's nonsense, but how can you make tumor grow faster? No one believed in it except few groups, and they struggle to make definitions. So you're kind of starting from scratch. Maybe they got some help from mathematicians. So imagine yourself being the pioneer of a field. And it's not like a PhD. These are MDs, like in clinic, looking at this odd phenomenon and try to define it and understand the mechanism. And they did their best to put in what made most sense clinically. Okay. So this is really a field like clinical science. There's a lot of clinical science here. But I think mathematically speaking, and well, I get the clinical meaning. So even if you think the tumor is exploding, it can't explode 1 millimeter to 1 millimeter to 15 millimeter. It's an explosion, but it doesn't do anything clinically. Like 1.5 centimeter is not going to be symptomatic, and you're not going to call it treatment failure because lymph node normal size is 1.5 centimeter. So it has to be a clinical deterioration. So I do, and then it's a fast deterioration. So if the 2 month is there. So all these things are clinically important, not scientifically important, but not mathematically important. So you have to think hard, like if you are the pioneer of this field, what would you do? Well, so put yourself in the shoes of others who actually pioneer the field. It's very interesting to see, what they actually have done. And now we're doing meta-analysis. Now we have Northwestern data, thanks to your all help. And Yuno is writing the paper, and Minjung, you've been helping Yuno, right? So
No, I haven't been able to.
so what definition did Yuno use?
you mean based on Dr. Hyunsun's?
Mhm.
I believe they used the Sada Buzira et al. The TGK ratio greater than 2.
TGK, and then did they use the progression?
I don't remember right now. I can look it up.
So we did it because that was recommended by our Northwestern radiologist group.
Mhm.
And that's what they've been doing with, you know, other tumor types. So we had to be consistent. I didn't
Right.
pick these.
Right. I think it should be here. Yeah. TGK ratio. Yep, defined as TGK ratio greater than 2.
Okay. In TGK, they don't have the resist progression definition, or no?
Does not.
Okay. So it's simple.
That's the biggest advantage of using the TGK calculation.
Hmm.
But do we have these numbers with us? Or no?
The calculated number?
Mhm.
I think we do. Yeah, I think you know should have access to the raw Excel file that has the
Because it's not that difficult to add the criterion of progressive disease
right.
if you just have the measurements, because you only need to like do the delta as you mentioned
Yeah.
for after receiving immunotherapy, check anybody who has a difference greater than 20%, then that is adding the criterion of progressive disease. So if we just have the numbers, it's not difficult to add that criterion.
Yeah. Good point. Anyway, are you done, or are you
Oh yes, I'm done.
you're
Oh
not?
wait. Oh, so yeah. I've been contacting
Yeah,
others and
your updated results of meta-analysis. So when you apply, oh, so you're waiting for them to give the full data and then you'll rerun it. Is that what
right,
you're?
right. And I have one more update. Sorry.
Uh-huh.
And since it's been such a long time since we first collected the data, I went ahead and
Got some
checked
more.
the publications that have come out since then. There were a total of 137. When we first did our analysis, I think there was a total of 430 somewhat papers. So I went ahead and sorted out the ones that we could use. And out of a total of 93 without duplicates, there's I think 6 more that we can include in our meta-analysis. And I'm going to ask Dr. Youngkyung and Dr. Daniel to just recheck that I sorted it out properly
Hmm.
one more time, because yeah, that's how it should be done according to the protocol.
Okay.
That's all for my update. I'm so sorry that I took up 2 hours.
No. It was a good learning experience for everybody. And as you can see, they're now looking into what are the clinical features, what are the mechanistic explanations, genomic and all that. So I know the meta-analysis, the technical part took up a lot of time, but hopefully you'll update the mechanistic updates from these papers. Clinical features associated with hyperprogression and so forth.
Right. There's one paper that we cannot include in our calculations, and that's because they used so there are 3 papers that used radiomics based approaches, but when they did their TGK TGR calculation, they did it the old way. They just took the target lesions, measured the longest diameters, and then went ahead with the ratio calculations. But the group by Samsung that I described before,
Huh?
they purely used radiomics and added up any region of growth. The reason why we can't include theirs in our calculation is that radiomics cannot distinguish new lesions versus old lesions. And currently the resist-based criteria does not add new lesions to the sum. Does that make sense? I'll pull up another paper. Sorry for the
Oh, it's
scroll.
good.
So these are the different criteria that are used to evaluate response.
Mhm.
And this resist 1.1 is the criteria that we see most often.
Yep.
And the limitation of using resist in evaluating hyperprogressive disease is that when you have new lesions, it's considered progressive disease, but you don't include the new lesions in the sum of the diameters. Does that make sense?
In the sum of the diameter, because it's not target lesion to begin with. Because,
Exactly.
yeah, you only follow the target lesion change.
Right. What's different about IRRC, which is a criterion that the Kurzrock group used, is that it's bidimensional and it incorporates the new lesions in the sum.
But the definition
Mhm,
for the hyperprogression, let's say TGK,
mhm.
is only resist based, so they don't, if the new lesion pops up 3 centimeters, that's not included.
Not included in almost all of the papers.
TGK and TGR both.
Exactly. And that is what people say is the biggest limitation about the current evaluation method, because they believe that the new lesions should be incorporated. And that's the reason why IRRC was created, because they realized when people were going through immunotherapy and had growth, they realized that they needed to account for the new lesions. But the problem is that IRRC, when I looked into the literature, is currently used mostly in clinical trials, but it's not used in the clinic. Most of the clinics still use resist 1.1. So when they calculate the TGR and the TGK ratio, it doesn't incorporate the new lesions into the sum. And so
One more question. So
Mm.
TGR, TGK, do they use the 5 lesion in total, 2 per organ criteria too?
right.
Both, okay.
Mhm.
Yeah, which is also not fair.
I agree. I think even if the mathematical modeling that I do after I receive the data, even if it's not statistically significant, I think one conclusion we can definitely make is that there is a limitation to the way hyperprogressive disease is being evaluated right now. And I think the radiomics approach, where you account for all of the lesions, is the most comprehensive.
Yes, and the new lesions.
Right.
Yeah.
And that's why some of the definitions actually included new lesions as a criteria, but they didn't include it in the sum. So
What about that Samsung group, Kim et al.? Did they? So they did volumetric, but to define whose hyperprogression, they didn't put the volume of the new lesions.
they did, because the problem with radiomics is the machine can't recognize what's new versus not. So it just adds all the lesions.
So
So
they
it
didn't
does
go by resist at all. They just ignored
in
resist.
not right, correct. But I think this is the most accurate way of doing it. And
I guess what Samsung did is the future. I think that's what it should be.
exactly, I
Yeah.
agree. And I think the reason why the radiomics approach is most appropriate is that they describe how tumor lesions aren't actually spherical, how the shapes are very irregular and polymorphous. And so it's only by radiomics that takes the lesion level approach and sums up all of the lesions that you can get an accurate volume of the tumor. And this is a problem, especially with tumor types like melanoma, because it says that on the CT, the tumor lesions aren't accurately captured for melanoma patients. Because I guess because by being on the skin surface, it's harder to, I don't know, harder to see the lesions on the imaging. And even for some types of lung cancers, the lesions are very, dispersed in a very weird atypical pattern.
Yeah.
And just adding the sum of small lesions doesn't accurately represent the tumor volume if you just take 5 biggest lesions. So yeah, I'm definitely going to include that in our discussion.
Yeah. And there are cystic lesions. Think about it. It's hollow inside.
Oh, right.
Sometimes the tumors grow inward.
Mm-hmm.
And sometimes it's just the pleural thickness,
Mm-hmm.
which with resist, we just call it non-measurable lesion.
Mm-hmm.
But with volumetric analysis, it is clearly measurable if you just track, the thickness, the 3D volume of the pleural disease. So I think we'll, in the future, where let's say Grace and Eileen becomes a practicing physician, I I think we will have a scanner that will just boom, and then you get the volumetric analysis.
Right.
Yeah, and then no one will be doing this primitive resist anymore. I think it's very primitive. I just feel like the fact that we're still doing it, it's like you would think we're gonna be over EKG era, but we're still doing EKG.
Mhm.
It's yeah, we're so I I think that's the future. And yeah, I think you got all the valid points, and all the things you told me, definitely make sure it's reflected in your discussion.
Mhm.
So yeah, that's why I think we should do, we should with Northwestern data. So because you've studied so much, Minjong, I know you will be studying USMLE and so forth, but make sure you just help kind of give him like inputs, like insights that you have
Mhm.
to be reflected in, because it's just all our Northwestern data. So my long-term plan is to see, with different definitions, what are like, what's the incidence, and then really do volumetric, like Samsung did. And with that, compare. Did Samsung compare traditional and volumetric?
So there are 2 papers from Samsung based on the same cohort.
Huh?
The recent one didn't do a comparison. The first one did, but the problem is the reference that they used, or so they called it TGK ratio based on resist, but it's not. It's they took the TGK measurements, applied it to the volume equation by Champiat, and then they subtracted the volumes. So they didn't use an exponential growth model, but they just transformed the length into a volume and then did the delta.
So they mixed it. Yeah.
Exactly. So it's very, yeah.
Interesting. So everyone's doing whatever they want. Okay.
Sports.
Okay. yes, so everyone will have different model.
Mhm.
So I feel like so the question for all of you who are listening to this discussion. So what do we need? I think what we're gonna need is someone will, if you have the, let's say, the CT scan, you're gonna need radiologists still to say what's tumor or what's not tumor. I've seen radiologists measure uterus and called it tumor. Okay.
Oh no.
I've seen so many human errors, and we cannot rely on AI to say what's tumor or not. They can help, but it will be the radiologist who's going to say this is tumor of interest, you know. And then when they click, 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 the computer will, calculate the volume. And then, they by algorithm, by different definition, it will say this is based on the 3 consecutive scans, this is hyperprogression. It will have an alert sign. So it's almost like, Lunit or just AI company making this type of algorithm built into a electronic radiology system, and they will sell these softwares. Okay. So implementing that into clinical practice, and people who are reading Epic, how do you have that pop-up sign? This is hyperprogression. So that's the implementation science. Building the interface. How do you put that in the Epic, and the Epic will have the, how do you work with the radiologist who's, how do you do the volumetric analysis and do that calculation? And there has to be an agreement in the radiology community that the volumetric has to be the gold standard. And to get to that point, it's gonna take a few years, right? So, so I can only like see what has to happen and how long it's gonna take. But we know the future, and so the next step is maybe work with the AI and the radiology companies to really accurately measure. And so I can see, Minjung and Peter and I can work together with Lunit and develop a, best algorithm to calculate uh, hyperprogression. And some end users want to know, I only want to use this criteria, and we can tailor to that needs. And by all different definitions, what the computer would calculate the growth ratio and all that. And that could be the Lunit's uh, algorithm that they're gonna sell, because they they made the COVID-19 pneumonitis algorithm. So they can make hyperprogression algorithm. It's just a lot of computation and volumetrics. But if there's a demand, there's going to be supply, and people will pay for that service, and could be paid by the hospital. And I think it's going to save patients' lives. Like once oops, I'm actually making tumor grow faster, then they'll stop immunotherapy and not continue and see what happens. Any comments, Minjung?
I agree. And the benefit of radiomics is not only the accuracy um, of measuring the tumor burden,
A
but
prediction.
it's also in that in one of the papers, they describe the tumor microenvironment basically.
Hmm.
Um, it's not exactly in the papers included in the meta-analysis, but I looked into the literature and they've been trying to quantify the different kinds of lymphocyte infiltrations around the tumors to predict prognosis. And in the case of one of the papers in our meta-analysis, they found out that vessels tend to be more tortuous around patients who have hyperprogressive disease. And I think that there's definitely more than just tumor growth. It's the tumor growth is also affected by the blood supply surrounding it. And I think the differences that we may be observing across tumor types may be related to factors like the amount of blood supply surrounding it, the amount of infiltration, which I believe would differ from organ to organ. So I think it's a really exciting field. And
Yeah. So, where is the tumor organ?
Mhm,
Whether it's primary or metastasis, where is the ground?
mhm,
And what's the originating cell? And then what is the nearby vessel look like?
mhm,
And where, where are the immune cells? And then texture, im-
right, right.
immune infiltrated organ versus non-infiltrated by radiomics, there's gonna be some change in contour and the
Mhm,
density and all that. So that human eyes cannot detect, the machine can.
right.
So how do you extract all that information, put that as all the variables, and let AI figure out the best algorithm to predict?
They
Uh,
only describe it as textural differences right now, and they haven't been able to build a model yet, but
Mm.
they're working towards it. So it's really exciting.
It is exciting field. Well, we're not radiologists, so our job is let radiologists figure out the best radiomics model, just the radiomics, texture and all that. I mean, we can use the best model out there, and then we incorporate, genomics, pathomics, everything else all together. So that's our job as a clinician.
Mhm,
But hyperpurgation is such a important and unmet need. Best define it and then best predict it. We need to make progress here, and how to prevent it. So data showed that if you combine chemo, you can definitely prevent it.
right.
Yeah. So that's why I like to add carbotaxol to nivo-ipi, at least first 2 cycle. That's the 9 LA regimen.
Mhm, mhm.
You, Minjung, you remember that regimen I give in the clinic, right?
And it in our meta-analysis, I think 2 papers suggested something similar to what you said.
Mhm.
How in one paper, even if somebody had progression, even after using immunotherapy,
Mhm.
when they use salvage chemotherapy afterwards, they had better prognosis compared to somebody who didn't receive immunotherapy.
Huh.
And so their hypothesis was that even if it causes even if it causes hyperprogression, the fact is immunotherapy is definitely waking up the immune system so that when you use chemotherapy afterwards, there is a treatment effect. And the Ferrara group here also, I think, published a paper this year related to that, where they tried adding chemotherapy and they had better results.
So compared to what?
I believe
Progressor followed by chemo compared to what?
compared to, I believe, immunotherapy progressors who didn't receive any therapy afterwards.
Oh. Okay. I don't know what they did.
I'll read the paper.
Yeah. Let me know later, because you assume most will get chemo, but that's another. So I actually have a paper on that. We like couple years ago in my group. So we looked at people, and this is consistent with all the phase 3 data. Immunotherapy followed by chemotherapy versus chemotherapy followed by immunotherapy. People with immunotherapy followed by chemotherapy do far better. Far better. It's probably some preconditioning. We used to think that chemo would kill cells and lice, and then immunotherapy would sensitize, the immune cells would be sensitized. So we thought chemo followed by immunotherapy could make more sense, but no, the data is opposite. People who get immunotherapy live longer.
There's actually similar data for neoadjuvant therapy. So they thought that if you do immunotherapy after removing the tumor by surgery, it would be better. But they're finding out that if you do immunotherapy first and then do surgery, the results are better. So I think there is something behind, as you said, the preconditioning and the waking up of the immune system.
Right. Yeah. Because post-surgery, I mean, your tumor's gone. There's maybe micromets, but yeah. So we're learning a lot, but yeah. So yeah, we stay excited. Thanks, Minjung, for the comprehensive review of what you've done, and I think you've shown yourself that you're very thorough and you are a good communicator. It's not easy to get all the information from different authors. So I think all of you guys who listened learned from the whole process. It's not easy, but you take it all the way. I think, Minjung, I think you developed interest and you are very persistent, and I commend all your efforts, and soon to come the final outcome. And then thanks for updating the most recent papers. It's not easy, but I think you're almost there.
I think I've had you say almost there more than 5 or 6 times, so I'm sorry for the delay.
That's okay. So this, I think, one more lesson that I want to tell all of you is, Minjung, as she discovers few minor, or could be minor, or it's kind of in the eyes of the beholder, but minor or significant flaws in classification or calculation, you don't stop there and try to, I'll just not do this because it's going to take too much time, but you pursue, like, well, to be more accurate, I think this is what I need to do, and if I need to get more data, raw data, or clarification, you communicate, you get to the bottom of it and not stop. But it costs time, energy, but I think that's a great asset to become a good researcher. So thank you for embodying that quality for us, Minjung. It comes with price, but I think you are growing through this experience. And imagine you doing this during residency or clinical training, or during medical school, or anything like internship, residency, fellowship. It's hard. You're not gonna do this type of intense research. This is only time for you to grow by spending your full energy, full time, in depth. This is how you can grow, because if you are busy clinically, it's so hard to set aside time to do this type of research. Undergrad, maybe, I mean, undergrads are busy, but you have vacation time, so you got some time. But once you get to medical school, internship, residency, fellowship, it's so hard. Your clinical duty is first always. But I feel like this is a great time for you to really invest and learn and grow. So I want to tell you guys this dedicated time is really valuable. All right. So much of that. Anything else, Minjong? Is that
No, I've spoken for way too long. I'm sorry.
okay? So good job, and yeah, keep updating us as you gather more data. Uh, let's do 5 minute bathroom break and resume. We'll get to all of you soon. Okay.
Thank you.
Thank you, Minjong.
Thank you.
Okay, I'm back. Okay, Eileen. Have an update for us? Oh, you're muted.
So me and Shauna, I think,
Yeah, tell me.
one major like idea or thing that we were considering is having a more organized drive. So we did have a Google Drive for like pacemakers and stuff, but it wasn't exactly very organized. So we're thinking of like making a spreadsheet of some sort to make sure that like all the video ideas and like interview things can all be like found in like one place.
Yes.
And then also, I know that we used to have like a Notion page, so we were considering maybe we can start using that, do it through there instead. So I tried logging in because I had the login info from the summer, but it seems that I can't log in because there's an email attached to the account and then you have to like verify your account info first. But I don't have the info for the Gmail account, so I can't do that. But if not, we can just do Google
Yeah.
Drive, which also works very well.
Minjung, do you have it?
Pardon, do I have the
Notion?
uh-huh the Eileen
Oh,
can take-
I can like privately text Dr. Minjung about it too, but I think honestly, I think more than Notion, I think Google Drive might be more useful for us because like spreadsheets might come in handy and just
yeah,
like put in-
I think Google Drive would be much
yeah.
Notion is just better for brainstorming purposes.
Mhm.
Sorry, I was trying to do the math right now. I was
Oh, yeah.
but I think you're right, Dr. Chia. I think they subtracted one. I mean, they should have subtracted one
Right.
from y, and I think that's how they mislabeled the y-axis.
Right.
But I'll keep on working on it.
Yeah. Even the published papers have, flaws, and you'll be amazed that, this could have been picked up by the reviewers, but it's hard. It's hard.
Mhm.
Anyway, Minjung, work on the TGK, how that graph came to be that shape, I
Yeah,
want
that's extremely difficult. But
to.
I've been doing it during the break time, but I'll stop talking. Sorry, Eileen.
So let's make a Google Drive and maybe like a timeline and who's assigned to what, and then what's the given 4-week timeline, and when is the group's next meeting, when is the interview date, things like that. We need a tracker. Yeah, you're right.
And I know that each of the undergrads are like taking responsibility for one video. And I think the last time we had like an undergrad meeting with Dr. Liam, he mentioned that Dr. Sungi was in the process of reaching out to the patients, I think. So I think we're waiting for a response or like the phone number to contact the patients that he
Dr.
wants with.
Singhi?
Or
I don't think Dr. Singhi has access to the phone numbers.
oh, well, I just remember Dr. Liam saying that he was working on getting the phone numbers to us.
Oh, that's easy. Eugene, you can give it to them today.
For sure.
Oh, okay.
Oh, okay. Seungmi says she already said phone
Oh,
number.
maybe it was Dr. Sunmi. Sorry.
Singmi, yeah.
Hmm.
So you didn't get it, Eileen?
No.
Singmi,
Oh,
where
that-
did you send it?
I sent it to Liam.
You sent to Liam?
Oh, then Dr. Liam might have not just been able to update me with the phone numbers yet.
Oh yeah. So Singmi
Yeah.
just sent directly to Eileen and Grace and Sally.
Okay.
Yeah, because you know who they are
Yeah.
to. Yeah. So so remind me, who's interviewing who? I know I told you guys, but I wanna.
I do not remember the exact name of the patient, but I'm taking on the
You
first.
have the list, right, Singmi? Singmi, you don't have. Do you have video? I can't see you.
Oh, Sungmi told me like she has a problem with logging in, so she needs 5 more minutes to join this Zoom meeting.
Okay. Anyway, Eugene, oh, do you know the assignment? Who's
For me, like I'm gonna interview Vivian with Sally,
okay?
and for other patients, honestly, I don't know yet, but Sungmi can, I think she can tell us.
Yeah, the mean, yeah, I have this organized in a document. It has everything we need, including who's doing who, and the phone numbers and the questions we organized with Dr. Che, like the core questions and the other questions, and also the medical summaries of each patient is all in one document. It's all ready. So all we have to do is get everybody, get each team of I think 3 or 4 people, like including the patient, just set up a date so we could do the interview. And before that,
Who's
yeah,
your team, Sungmi?
I'm with I'm doing Paul Shaw, and I think I was with Grace.
No, not Grace. Grace is not involved this time.
Is that Irene? So I'll have to open the thing. Wait.
Can you share that document?
Yeah, we'll do it now. Okay. So I'll be sharing right now. Interesting. Here. So can you see the screen?
Yeah.
Good. So, oh, okay. Sorry, that part is not full yet. But this is the document that has all the details, including what we need to do beforehand. Their email, so we send them the questions and ask them which ones they would like to be prepared and be asked, and their numbers. And I guess the interview and assistant part is blank at the moment, so I'll fill it out with Eugene, or I could use the lab meeting from last week and fill it out.
So let me.
I think I was gonna do Mr. Curie, Albert Curie.
Okay.
So who's doing Curie?
Oh, Eileen.
Eileen. And who's the physician? Liam?
I think so, but I can also check the lab meeting from last time and check.
So maybe you're doing it with Emma, Eugene, and Sally. I think Sungmi and Emma.
Oh yeah, that's great. Yeah.
I think it was Emma. Yeah. So this is the initial 3, and then we decide to do Songhyun Park.
Yeah. I couldn't find them, so if anyone tells me his full name, I'll make his part.
So
I will
Songhyun
help her.
Park, Isil Kim will do the interview, and Eugene Oh will do the take the film do the video.
Yeah, I will.
Dr. Sumi, is there a way that you could share this document with the undergrads so that we can also
Yeah.
take a look?
Yeah, just put that in the chat box so that you guys all have it.
Okay. Nice.
Make sure it's shareable to anyone who has the link.
Thank you.
No problem.
And for all the videos, I work with Shana because she's working remotely with us,
Sure. Yeah.
and she can add clips, she can work with you.
Yep. Sorry, I'm not good with computers, so I'm trying to find how.
In all the videos.
Okay. Yeah. There.
Show. Okay. Yeah, Eileen, go ahead. Any updates?
With the Wix thing with the Instagram,
Yeah.
I did the like customer care center like live call chat thing again, and we still failed to fix the problem. And they keep like every time I do it, they say, "Oh, we'll send an email. Like a person from our care team will like reach out to you," but I have yet to receive it. But yeah, so I don't know what to do regarding that.
So it
And then
simply cannot be embedded. Huh.
yeah. So right now for Instagram wise, the only way we could do it is just having like a link to our Instagram, like a button. But
Okay.
luckily the YouTube videos don't have any problems. And that's
Okay.
also another big factor in our social media.
Okay.
So
All right. Just try one last time, and if they still give you trouble, just one link will do. And
okay.
I think we'll assign. I think Instagram, because Zoe was working on it, so I feel like we don't have to create like a new Instagram messages, but use Instagram to sort of be a link to get to our homepage or get to our YouTube. I think that's the only. I think that I'll just have that as our only purpose of having Instagram. I feel like yeah, and then if you, for some of you who have Facebook, you can just share. You can just share the YouTube videos that with the link of the homepage to sort of advertise what we're doing. I think that should be fine. We don't need like separate Facebook page.
Yeah, the Facebook page, the only reason I had made it is because in order to display the Instagram, it has to be linked to some sort of Facebook account. But
Oh, really?
yeah, it wasn't for purposes of like using it to advertise.
I see. I see. Okay. Okay. So is our homepage ready, Eileen? Then are you done with the history part?
Yeah, everything's ready.
Everything's ready.
I think the Instagram was the only issue.
Okay. 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 And then you were saying, I think we can, I don't know, like, I think we can leave the admin as is, and then with the new admin, and we'll, we will, with the new people coming in, we'll see who else apply, will apply for our pacemaker movement. And then I asked Sally to look into, registration for like NGO and school chapter and all that. So we'll be a school chapter in undergrad campus as well as a Feinberg campus. But it will be open to high school students. It will be open to non-Northwestern. And then we'll begin, and then we'll among those people, we will select like a new admin who's going to be the core admin, and then people who are newly joining are not can't be the core. They don't know the history, so they're sort of like the they'll be assigned tasks, and they won't be part of the planning committee, but I think we need a more core planning committee, and then we have people who will actually do the work, interview and write essays and things like that. So I think once we have more people, we'll have a leadership meeting and then decide on who's going to be the core admin, and then restructure the team member homepage that way. Any thoughts on homepage or the future directions? Any opinions, suggestions? So it's not like we're interviewing celebrities. It could be anyone that you know, that you want to interview, and there's some lesson to be learned in terms of doctor-patient relationship or patient support or patient family support. Just as core members, everyone here is core member, and just give me or Iser or Eugene or Seungmi or Liam, give us your input, suggestions, and we're happy to set up something for the new interview. It could be your parents, it could be anyone that you know that you can comfortably reach out and share their life stories. I think it's only by sharing stories that people can, change. Okay, Eileen, anything else?
No.
Okay, are you gonna work on the variant project?
With Grace.
Yeah.
Yeah. I just haven't been able to make it to the meetings because I think especially with the COVID situation I was in, it was kind of chaotic last week for me.
Sure.
Honest. Sorry.
Yeah, hopefully it will be done. And
Yeah.
next Monday, the Illinois won't have mask mandate anymore.
Yeah, that is crazy.
What about Northwestern as a school? Will they maintain mandate in
I
class?
would think so. Yeah, they definitely should. There's definitely been a surge in cases
Yeah.
last week. So
Yeah. But at least we won't see it in restaurants and other places anymore. Yeah.
yeah.
I think hospitals will definitely keep that. And then public transportations, airports, train, these are federally mandated mask policies. So they're not affected by the Illinois policy. So just FYI. Okay, Grace.
I have a bunch of questions about the variant classification project.
Let's do it.
I'm gonna share my screen. So I started organizing an Excel sheet that I could just send out to Eileen and Lena, and I can use so that we could just put our data all in one sheet. The only thing is I started this is like the list of stuff that you gave me before.
Yeah.
And we said we'll just stick to the list that you generated instead of
Yeah.
going off like a standard definition. So when I started, and you said just doing ClinVar and OncoKV instead of My Cancer Genome too, right?
Yeah.
So I went ahead and I tried looking up all of these in both databases just to see if they show up or if there's like some that we could just exclude.
Yeah.
So for PIK3CA, okay, first question. In ClinVar, like when you search it up, for example, if I go through PIK3CA, and then I do all the filters, there's a lot of different conditions, and we're trying to find if it applies to lung, right?
Mm-hmm.
So there's squamous cell lung carcinoma, there's like lung adeno,
Right.
and there's also like sometimes small cell, sometimes non-small cell. Are
Right.
we including, I know we're including non-small cell, probably not small cell, but do we include like squamous cell or lung adeno? Like which ones are we supposed to include?
Yeah, squamous adeno are non-small cell.
Okay, so everything but small cell.
Correct.
Okay, cool. And then,
How many of them are there?
oh, I don't know. I PIK3CA has like a few.
But how
Some
many
of them,
lung?
huh?
How many of them are lung that are pathogenic?
Oh, I didn't go through everything. That's what everyone else will have to do with me.
But 99, is it 99?
Well, 99 came up. Not all of them have lung associated with it, and not all of them are going to be pathogenic, probably.
Can you sort by lung, or you have to manually just look
No,
at it?
you have to manually do that, which is like the really annoying part about this. And it also says like likely pathogenic, but it's different for each condition. So we have to go into each one and then see what it is specifically for lung. Like here. That would be likely pathogenic for lung.
So but it's the same variant, right?
Yeah, but sometimes depending on the condition, like the interpretation is sometimes different.
I see.
Yeah. Which is why you just need to go in and check. Which is why it's just tedious.
Right. So remember when your prior abstract,
Yeah.
let's pick FGFR, right? You pick
Mhm.
there was only, how many variants did you have for FGFR?
I don't think we did oh, did we do FGFR?
Yeah, let's go back to what you did before.
Um, uh, wait. Mm,
So that's RET.
oh, FGFR. Here.
Yeah. So you got these mutations. FGFR1. Yeah.
Yeah.
So you included all of these in your calculations, right?
Correct.
Yeah. And this is from all solid tumor other than lung, right?
Yeah, I mean, this specifically is for biliary.
Oh, that's for biliary. But did you see these variants in biliary, or it could be any tumor when you got these?
So what we did was we only chose the ones that were applicable to biliary according to like ClinVar and OncoQP.
So it did say histology biliary, right?
Yeah, like it listed it as, like, for example, for this variant, under the conditions it's found in, biliary was one of them.
Otherwise, it would be much longer list, right?
Yeah,
So go down to FGFR2. That's also biliary. Is that
yeah, this sheet is all biliary.
okay? And then we couldn't do fusion, so so for
No.
FGFR2, you actually used all this data, right?
Probably everything except for fusion.
Everything. Go down FGFR3. Okay. Okay. And how labor intensive is that? Is it to do this long list of variant for each, like each gene? Do you literally have to do a lot of
Yeah,
that?
it's really, yeah, you have to click for each one and then scroll down and find each one. It's just a lot of busy work, not hard, just a lot.
So what I'm thinking is, just for the abstract, if for something like BRCA, it could be a much longer list. And I'm thinking, just for the abstract only, I feel like we could do the first 10 that pops up in in the ClinVar under the lung. Let's say FGFR1. And
So we could do that, but for stuff like, for example, like HER2 for lung, like there is some, maybe not HER2 or STK11 for lung. There's probably like less than 10 for those.
yeah, then it's fine.
Okay.
I just don't want you guys to spend too much time for abstract.
Mhm.
So I think you could put that, you know, a representative, a max, you can put max of 10 representative, you know, variants found to be in the lung, in non-small cell lung cancer was selected for the purpose of this, you know, comparison of concordance or something. I think you could do that for the abstract, and then for the actual paper, you could get the full list. Does that make sense?
Okay.
That will
Yeah.
significantly reduce the workload.
I'm just thinking because like in the end, we're gonna have to go through both ClinVar and OncoKV and select ones that are the same for both, right? Like for
Yeah.
example, if this said it was pathogenic and this said it was benign, we're not gonna count it. But if they had the same, then we are gonna count it, which so then we'll probably have to find a list of more than 10 because there will be some disagreements and then choose 10.
Okay. For that purpose, let's go by ClinVar. Let's forget OncoKV for the purpose of abstract. I just want you to be able to finish it in the timeline first. Let's do
Okay.
ClinVar for the purpose of,
Just do ClinVar.
yeah,
Okay.
that
Um,
makes it easier. And then by ClinVar, you get the first 10 that's long. If it's
yeah.
10, get all of those.
So in that case, when I looked up mTOR
Uh-huh.
and FGFR and IDH in and HER2 and KEAP1, in ClinVar, they didn't have any variants that corresponded to lung.
In ClinVar?
Yeah. So for example, mTOR,
Wait, is
which is,
ClinVar only looking at germline?
I don't know. But like for these, there are a bunch of mTOR variants. It's just none of them have lung associated with it. And it's like that for FGFR 1, 2, 3, IDH 1, 2.
What about OncoKB? Let's see if they have anything.
So OncoKV is like, this one was also something I had a question on.
Uh-huh.
For example, mTOR.
Mm-hmm.
So we have mTOR. Non-small cell lung cancer is listed in like the cancer types with mTOR mutations. So
Yeah.
it's here. But also it has something. Oh, what happened? Sorry, give me 1 second. So this one. Okay, it has this section called therapeutic.
Uh-huh.
Oh wait, no, I can't see. Okay. And before what we did with when we did the previous like variant classification project, for example, if I was like looking at this for bladder, I would find that, oh yes, there is a therapeutic associated with bladder. And then we would go through it because what we were doing was looking at like put like actionable targets, right? This
Right.
time we're looking at non-actionable, so lung shouldn't be here, right?
Drugs?
But there's this, yeah, for lung cancer shouldn't be here yet.
Uh-huh. Right.
But there's this category called all solid tumors where there's like apparently a drug where that can target mTOR within all solid tumors. So does that mean we can't use this because it's not potentially actionable?
It's potentially actionable, but I want to go by the what was actually found in lung, but it's not it's not clear.
Yeah, I mean it does say mTOR mutations are in non-small cell lung cancer. Like it's here.
But how can you find them? How can you search for lung? Can you search for lung?
No, like the OncoKV is a little less specific, which is why we like for the previous project, we just like listed everything here and then cross compared it with ClinVar and my cancer genome and hope that would make it specific, like enough to lung. So using OncoKV alone probably won't be a good idea.
So
Also, like
Look, click on one, like likely oncogenic gain, likely gain of function. Click on that. And does it say histology? Does it say where it came from? It just says all solid tumors.
Yeah.
Oh. Can you select cancer type here in the top
Huh?
cancer type?
Um,
Oh, non-small cell.
I mean, it's non-small cell is programmed under all solid tumors, so it'll just give the same information.
Ah, so it's not specific. Got it.
Yeah.
Okay. So I don't think this using OncoKB, we can say which is coming from lung cancer. And my
No.
cancer genome is even less information
Yeah.
here. What about
It
C?
has
Can you go to C Bio portal?
oh wait, what happened? Oh, sorry. I not really used CBio portal before, so I don't know like how to use this for variants.
Yeah, go to lung cancer first, maybe. Yeah. So lung cancer has all, yeah, non-small cell lung cancer has all these studies. So you click on every study.
Do I select these two?
Yeah, everything. So this is their database.
Yep.
Yeah, that's all under. Yeah, so within this data, well, there's
Mhm.
lung cancer, thoracic cancer, thoracic PDX. What is thoracic small cell? Huh. SMC, is that Samsung? Yeah,
I'm from medical center.
yeah. Click on lung cancer and thoracic cancer.
Not this one.
Lung, not that one. That's PDX, is animal model. And then you click query by gene,
Mm.
and then you put that gene. Oh, there's copy number alterate. Just click the
No.
can you
You can just put the large capital like to select all.
Wait. Hmm? Oh my gosh.
select. So
Thank you.
structural variants, copy number, to unclick mutation, click structural variant. No copy number, no, unclick. Structural variant is the, I guess the, yeah, see what happens. So each data will have shown.
Hmm.
Oh wait, the mutation type is all fusion here.
Yeah, there's no missense.
Oh, maybe we should go back and click mutation.
Okay. Mm.
Structural variant, yeah.
Mm. Whoa. Oh.
So now you have, so annotation is, to figure out what they deem as functional here. Level. Oh, this shows the OncoKB level of evidence here.
Oh yeah, the target thing is Uncle KB. This is civic. This is my cancer genome. Nothing.
Here, what is that?
cancer hotspots.
Interesting.
Yeah, so it looks like it combines all of these, I guess. Whoa.
So actually, it's OncoKB data here, and then you have level of evidence. So you could go by that.
Level of evidence.
Yeah, if you go to OncoKB, there's 3B and 4.
Mm-hmm.
Where's the biologic effect? Can you click that? Yeah. So anyway, likely oncogenic gain of function is all you need on the top, you know.
Mm-hmm.
Yeah. And then that was this mutation was found in non-small cell lung cancer. So you could go by, you know, like the first 10 from CBioPortal.
So just use CBioPortal since it uses multiple databases.
Yeah, and then ClinVar, you weren't able to get mTOR that way, right?
Yeah, no, it was weird. ClinVar didn't have it for a lot of genes, actually.
Yeah. So I'm wondering if they're just, yeah, ClinVar is, yeah, something's not right. Yeah, so I think this is the best, easiest way to get the first 10 genes.
Mm-hmm. Okay. So I'll go through CBioPortal, like see what it's like, and then I'll make a tutorial on how to do it, and like get Eileen and Lena to help out find the first 10.
Oh, yeah, you have to find first, or I feel like just for the abstract purpose, maybe it may be easier for Grace you to get the first 10 for the gene variant, and then have others work more on the calculation piece, so that, you know, like one person's doing the, you know, the variant, and the others working on, you know, calculating the concordance more.
Okay, so like the R stuff.
Yeah.
Okay.
So you do that piece less, and then you know, just get the list by yourself and distribute to other people. I think
I have a
for the
question.
purpose of abstract, that's faster.
Okay.
And then once we get to the actual manuscript, we can divide and conquer to get the whole list.
Mhm.
That makes sense? And
I
let's
do-
back to the variant list.
I think Eileen had a question.
Oh yeah.
With like the variant stuff, I feel like the R stuff, I don't think me and Lena, does Lena know R? Like how to
No, she
calculate?
doesn't know R.
Yeah,
Like
but
the
if you are
problem
in a
is
time
I don't
crunch of,
really
like,
know it either. So
okay,
Eileen, you
okay.
and I might need to figure it out.
Because I was gonna say that if we're in a time crunch, it might take longer for us to try to learn first and do it. So, but I thought Grace, you knew it too, but I guess not.
No,
never
I
mind.
like got a basic. I like no, I don't really
Okay.
So
know.
you don't have to know the whole R. You just need to know how to open R in your computer.
Oh, it's true. Just
Go
plug
and
in.
open, and then just copy paste that command, and make sure you enter those, you know, numbers and equations. And so it's a repetitive work, but yeah, I mean, it's, yeah. Yeah, go to the list. Yeah, so you got PIK3CA, mTOR, FGFR, IDH, PTEN, BRCA, KRAS, KEAP1, STK11. So KEAP1, STK11 is there for the, so when you write the manuscript, the abstract,
Mhm.
it's there to it's not only to select the appropriate matching therapy, but also to predict resistance to existing therapies like immunotherapy. So that's the KEEP 1 and STK11.
Keep one and STK11 can help predict resistance to immuno.
Yeah,
Okay.
so it's different. Definitely there's HER2. So there's BRCA1, 2, and FGFR 1, 2, 3.
Mm-hmm. And
Um,
I saw there was 1, 2 for IDH.
yeah. And then maybe I think you have AKT. There's one more AKT.
Okay.
And there is MEK, MEK.
Mech. Here?
Yeah, MEK.
Oh, I was confused about mech because
Huh.
when I looked up, for example, well, I guess we're not using Clinvar anymore, but for example, when I looked up mech and Clinvar
Hmm.
or OncoKV, like it gives like all of these different genes, like RAF1 and like
Oh.
BRAF and everything. And I saw like it's like all part of the mech like pathway, but I wasn't sure how to approach it, like
So
which
there's
ones I'm
different
supposed to
genes.
include.
So you have
Like mech is associated with like MAP2K1. Like it doesn't just show mech.
yeah. So MEK2K1 is the gene. MEK3K13. There's so many MEK.
So
related-
will we have to do all of these MAP3 like kinase, like MAP3K 2Ks?
maybe put that. Let's see what comes out. Put MEK.
For C bioportal?
Yeah, MEK2. Yeah, put that.
Just put map these.
No, MEK. Yeah, MEK2K. What was it?
Oh,
What was the full name?
one map
MEK2K1. Yeah.
I think you could do multiple here, right?
Yeah.
Oh,
What gene?
confused.
Hmm. Can you go up? Right here. If you click map 2K2 on the left side,
Map
then,
2K.
then it's the all 2K2.
Ah, okay.
33 mutations there. Wow, there's a lot. I mean, in fact, there's not only KRAS, but there's NRAS, there's HRAS, and there's so many in the pathway that could be. So MEK, so the protein is MEK1 or MEK2, but the protein that encodes could be different. And you have RAF and ARC, and all those could be. So Mac one. I don't know how thorough you have to be. So there's MEK1, 2. So that's the protein, and we need to get a gene that encodes for those, whether it's 1, 2, 3, And then you have ERK, ERK1 or 2, ERK1 or 2.
Oh, we're doing ERK too.
Yeah, let's do ERK. They're similar. What comes up in ARC? ARC 1 or
K1.
yeah, MAPK 1 and 3. That's S mark? No. So yeah, do MAPK 1 and 3.
Okay.
And for Mac, we need to, can you go back to Mac 1? Let's see what Mac 1 and 2 comes with. So Mac 1 is the MAP 2K1 and Mac 2 is the MAP 2K2. So let's just do both.
Is Mac 4 or Mac are these?
No, we're only interested in Mac 1 and 2.
Okay.
I think you could do similar work. KRAS is going to be difficult for you
Oh
because
yeah, I saw there were a lot.
KRAS is that's a lot, but so it's don't do KRAS because
Don't do KRAS.
don't do KRAS. The reason being we don't have good drug yet.
Okay.
Yeah. We have a drug that targets KRAS G12C, but G12V, B12E, B, all these things, we don't have good drugs yet. They're still
Yeah.
in the pipeline. So, our definition is it has to be actionable. So MEC, ARC, AKT, MEC, ARC is going to be like a, targetable with MEK inhibitor or RAS inhibitor, like KRAS, like a sorafenib. And then the AKT and P10 and mTOR are going to be targeted with the mTOR inhibitor. So above it, targetable, not RAS, but MEK inhibitor. Put MEK, RAS, MEK. Or MEK or RAS inhibitor. Just put, because sorafenib is a dirty RAS inhibitor.
Also, Dr. Che, I have to get going in like 10 minutes.
Oh, sure. So Grace, do you think with this list you can get 10 or less per each?
Yeah, I think if we just narrow it down to 10 each, that'll be faster.
Yeah. And then distribute among yourselves.
Mhm.
And Ether and Eugene can do a few. Ether and
For
Eugene.
sure.
Yeah.
Wait, a few for what?
The concordance, you can give some to Ether and Eugene.
Oh, to check for the data analysis?
Yeah. And then you have Eileen, Lena, yourself. Is that all?
Yeah.
Right?
Yeah.
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 So you can distribute, you can get less because you're doing the extraction,
Mhm.
and just distribute and give them guidance. Like if you need a Zoom call to go over it, a few together with them, maybe it's better to do that, first introduction Zoom call.
So everyone else will be helping out and like calculating. You mean like for like Matthew's
Yeah,
correlation coefficient and stuff like that, right? Like
yeah. So why I feel like, and then actual result.
Mhm.
Grace, can you write up the abstract too? Can you, and then I can help you and Yusuf can help you and Eugene can help you. But you can start the draft to the first draft. It's same thing as your prior. It's just
Yeah.
punching in different numbers.
Mhm.
Yeah, so let's set up that, timeline. You can get the variance in next 3-4 days and then distribute the work, variant list to each person, and then give them timeline, deadline. Yeah, I think it's straightforward from there on.
Okay.
And we'll talk about the actual manuscript once the abstract is done.
Yeah, sounds good.
Okay, anything else?
No, that's it for me.
Okay, I'm glad we had this discussion to streamline things.
Mhm.
It's not
Yeah, that
as
was helpful.
easy as it sounds.
Mhm. Okay. Thank you. I'll
Thank
get going to work now, but thank you. Have a nice day.
you too. Okay, Seungmi, do you wanna go next?
Sure, yeah. So let me show you the data. The screen share. So I haven't completely finished it, but I got rid of the non-lung cancer patients because there's only few. A lot of them are were stage 4 at initial diagnosis, so they did not go curative treatment. Only like a very small minority actually went for curative treatment. Yeah, so I'm not sure how to analyze this yet. I do realize that with Signatera, like the people who did undergo treatment, they are the ones who seem to have like very low numbers. But that's like that's my hunch, but I would need to analyze it. But this one patient, no, not this patient actually. This patient,
Who's that?
John Hinney,
Uh-huh.
he had a fat lobectomy, and then he had a new CNS brain metastasis. But his was like 0. So that was like, but like you have to see the whole picture, I guess.
So do
The
you know
thing is,
why?
no.
Because the CSF detect
Oh,
DNA, but it doesn't come out of CSF.
oh my God, that makes sense.
Yeah.
Yeah.
For these people, they do lumbar puncture to check
Yeah.
ctDNA.
Oh. Yeah, and I was just thinking that, like time of the initial like curative treatment and the time of Signatera, like for each patient, the gap between the period is all different, but I wasn't sure how I could incorporate that into analysis. And not everybody has like a landscape. Some people just have one. Some were canceled and stuff. So, and I was wondering if I should limit this study to only the people who got curative treatment, because that would probably go down to less than 20, I think. Because like,
So who is curative? Can you show
oh
me?
yeah, for example, this guy, the person who got the double lung transplant, Albert Curie. So he got double lung transplant in 2017. Oh no, wait, no, this person. So Albert Curie. So he got a lung transplant 2021. And then if you look at his signatura, they're both like stay 0. And he hasn't like, nothing has recurred. So I would say that's valid. And also this person who is let's see, also anyone who has gone through treatment. So one other person would be Mary Zarzabowski, and she had in August 2021, she had like lobectomy. So she was stage 1A3. And then if you look at her signatura, it stays pretty low.
So is there anyone after
Mhm.
surgery
Yeah.
had positive numbers? Or not?
So like the people who had surgery, there's only like very few. I don't think there was someone. This person had surgery, and no, the people who had surgery, they probably they mostly stayed like 0.
And that one before was pre-surgery?
I don't think no, it wasn't. So most of the so I don't think I saw any pre-surgery as of yet, but I haven't gone through all of the data.
So
I haven't seen a single one yet.
number 28,
This person, Harold Daniel is Sarah.
so is that patient post-surgery positive?
No, he's also post-surgery negative. Oh, he was sorry. He was positive initially. You're right, sorry. And then he became negative.
So we'll be interested to know whether he received adjuvant chemo or not.
He did. If you look here, he got carboplatin and gemcitabine.
So this case is great. The reason is post-surgery, he was ctDNA positive and
Yeah.
cleared it.
Yeah.
Did it
But
clear?
it is
Did it clear for good? Next question, right? So we will need, it's now 3 months after that, right?
yeah.
So let's make sure we get Signatera for that patient. I will tell my team that we should get one.
Okay.
So Harold, Daniel, what is the full name?
Harold Daniel, I've highlighted a bit. His
Yeah,
surname is,
Yeah, date of birth.
date of birth is 1949, May 10th.
Okay.
Are those the kind of cases would you be interested in finding more of?
Yes.
Okay.
Well, you have to, look at everyone first and
Yeah.
find what kind of trend you can find.
Okay. So basically, I should focus on Signatura. One other thing is with Signatura, is there a separate site I could go in and just type the patient's names and get the results like Tempest or not?
What do you mean Tempest?
Like with Tempest, they have their own site, and if you just they have their site online, and Guardian. I was wondering if Signatera has like a separate site where you can log in, type in the patient's name, and then you can get the results instead of having to go through the Epic.
I don't know if they have a portal,
Yeah.
but I CC'd you. Did I CC you to the Natera people
Uh,
in the email?
I
Let's
think
email,
so. Yeah.
let's email them together after this meeting. They may have
Okay.
a portal and that may be easier.
Yeah. So, and I should ask you more questions while I do this on the way. And one other thing is, I did try writing an abstract. I know like it's too early to write one, but I just tried writing one, like just the first half of it at least. So do you want to have a look at it?
No, I want to look at the full data first and
Okay.
look at the theme first. What can we write about?
Oh, I see. Yep.
Right now, what's the total number and how many have you looked?
So you gave me like almost 100 patients. If I take out all the ovary or colorectal cancer patients, it goes down to approximately 80 or 85. And then if I cut down all the patients with metastasis, then I can't say for certain, but it goes down to maybe less than a quarter of what's left of that. So maybe less than 20, between 10 and 20.
Hmm. So how many do you have so far?
I've half, and of the half, I only have about like approximately 5 patients, I think, who went some kind of curative treatment.
Five patients who underwent curative treatment?
Yeah, and of the half I've done, so I think it'll go up to between 10 and 20. Also, I wasn't also I would, now that I know that now I really know what the focus of the um study is. So I would have to go through these two parts, curative treatment part again thoroughly, and then I could give you a definite answer. Because I was like trying to fill up everything else and read up on everything else, and I wasn't really focused with um, gathering the exact data for the part that my study is focused on. Yeah.
So here's the way we should think about this project. So how
Mhm.
does ctDNA change over time?
Mhm.
The easiest study is looking at the curative intent, because
Mhm.
after curative intent treatment, did the ctDNA come back positive? If it is, we are likely to think that they are doomed to experience recurrence.
Right.
That's the easiest low-hanging fruit. Now, looking at, because we found that CNS recurrence will not be detected. We found that a lot of cases, effective treatment will bring down ctDNA to 0, non-detectable from decent
Mhm.
level. Um,
Yeah.
what's the denominator? Like, out of how many cancer, how many patients who started cancer therapy, will they see ctDNA go down to non-detectable? Just describing the landscape of molecular treatment response and how long do they last? That's another question. So, therapy monitoring is a big piece, and that's why I asked you to look at the gastric cancer patient data, and you should present that in our journal club. So we used to have every week journal club within our lab meeting. So we're gonna continue to do that. So you can start it, Sungmi. But that paper does look at the ctDNA dynamics, and that will give you the idea. So look at, there's some Samsung Medical School have written, a few ctDNA dynamic papers. Gardent has written some. So the ctDNA is used to distinguish pseudoprogressors from responders. So there are papers, and just like Minjung did today, how do you calculate the ctDNA velocity? There's a such thing. How do you quantitatively assess that there is a molecular response? What is the definition? What is the best way to assess ctDNA dynamic? And does the molecular response translate into clinical response? And what is the durability of that response? So those are all good questions that you can answer from our data set. It doesn't have to be the curative intent only. I want you to explore all the data set you have. And if you really like to see the non-lung cancer trend, you can look at the ovarian cancer too, and other non-lung cancer. But I want you to see first what you can do in this time frame. Now we're shooting for the lung ISLAC in Vienna. So that's why, for the time being, I want you to focus on the curative intent and just simply describe the landscape. Is it only one patient out of 20 that had positive and that was cleared by adjuvant? Then describe it in your abstract. That's it. Just the landscape. But for the whole 3 months, I want you to, look at the whole data. I want you to analyze the trend that you see, and then, pick and choose what are the themes you want to answer, all the questions that I told you, and read all the relevant papers and learn their mathematical analysis, and then try to apply that into our data. So that would be the direction that I would suggest. But for the time being, yes, right, the landscape paper, but only the look at the trend, analyze the data first, and then writing up an abstract is easy. You can do it in a couple hours.
Okay.
Any questions?
No.
Yeah, so this is another true clinical analysis. Now,
I was wondering. Oh, yeah, so I was wondering why the tumor burden is different for the different the Guardian and Tempest. There is a discrepancy between the level of tumor burden. So I was wondering if you have like an explanation or the significance of that.
what do you mean by tumor burden?
Oh, I meant TMB.
That's tumor mutation burden.
Yeah, tumor mutation burden.
Yeah, that's very different from tumor burden.
Yeah.
Tumor mutation burden is calculated in very different ways. It depends on what algorithm you use, what platform you use. So every company will have a different measure, but they have to be similar at least. So I want you to annotate those ones who have Altera. Altera is the one who
Mhm.
has tissue. And
Yeah.
I told you the TMB could be from Altera, could be from Tempest, could be from Foundation.
Yeah.
So comparing that TMB could be important. And does the TMB affect the ctDNA positivity or the outcome? Does it do anything? That's another question.
Also, I think starting to add the dates for the Altera, Guardian, Tempest, because like some people get multiple, so dates could be different because Altera would be at the time you get the tumor surgical sample. Guardian, Tempest is blood samples. So like I started writing the dates of collection rather than report, so that's more accurate, right?
Yeah.
And should I also start right? Some patient has had like three results of Guardian. Should I start adding that in, or would that be too much for this study?
So that's too much.
Yeah.
Only get the one that was done close to the resection, or
Okay.
only just get the one representative gardens. But for Altera, it's important to write down all the mutations and everything that was found.
Okay. So like with the mutations, sometimes there is this very slight discrepancy between the reported mutations, and usually it's like one would not detect something the other would have detected, but I would just go with the like of all this done, I should write all the detections that are done, right?
Everything that's detected by each test under each test name.
Oh, but then that would mean that that would mean that that would make things a bit more complicated just to write it in the Excel chart, because like let's say like BRAF mutation, then every test has like most of it would be coherent, but like let's say one had positive, others had negative, but then that would be a lot of data to input, but do you think it's worth it? Because for now I just did BRF mutation, and then if any one of them was positive, I just put one, like positive for one.
Oh, in the data set, you have to know by which test it was detected. So
Oh,
you use combining everything. You have
okay.
to list name of the mutations under each assay.
Okay. Can I ask you why that's important?
You have to know which one detected it, and was it tissue, was it blood? It's important to know.
It doesn't matter between the blood ones, but it's important to divide the tumor and the blood
So
DNA mutations separately.
the assay Garden uses, the assay Signatera uses are different.
Oh,
Which assay detected which?
okay.
You can't lump them together.
Okay, thank you.
No problem. And it's also important to know what's actionable, what's not actionable.
Yeah.
So some will say this is BUS, then you should write that's BUS.
Okay, yeah.
So
Also, it's a level, sorry.
it's writing, it's just putting all the genomic information in one place by assay.
And also sometimes like the level, like in percentage, is that important because sometimes it's so low, like it's like 0.1%, and there's clinical trials available, but some it's like in their like two-figure percentage. So is it important for me to write down the percentage as well?
So this is going to be a descriptive paper if you write a paper. And in the paper, you have to be as detailed as possible.
Mm,
We can either go back to that report, you pull it up again and write it in the paper, or you either put everything in the Excel file so you don't have to go back and look at the report one more time.
I see, I see.
Okay, so all those numbers are important, whether you, because we might not end up using all the numbers. We might say, oh, this case is not important. Let's write
Yeah.
more in detail about these cases. So it's up to you. The variant allele frequency, I will leave it up to you. We
Okay.
might need it. In that case, you might have to go back,
Yeah,
get those numbers.
I don't mind with that. Okay. That's it for me.
Yeah. Yeah, it would have been better if the numbers were high enough. I think
Like
10 patients, 20 patients, people don't know what's going on in lung cancer. It's still worthwhile reporting it. So make sure you
Yeah.
know all the MRD papers that came out in the lung cancer field.
Okay.
Because that's the only way you can claim this is the first paper ever to do that. You don't know what other people have done, you cannot claim anything. Maybe we're just doing the exact thing others have done. You know,
Okay.
did any paper come out using the Signatera platform? Do you know the difference between Signatera and Garden? Garden never looks at the tissue and so Signatera is the only one that gets the
Yeah.
case personalized. So has there been ever any paper? So the other question is, what is that 16 gene mutation? Did Altera report say what those gene mutations are? If they are not sure, and if they're not clear, then we can ask the company people to extract that 16 gene, and we can have a supplemental figure or table and list that all 16 genes for each patient, and then see if there's any overlap between the genes. What are the most commonly mutated genes that are used to create this 16 gene marker? What is the overlap between people? These are all very good questions. So I'll give you the Natera company contact email, and then you can email them all of these questions to see if they can provide us more data.
Okay. Yep.
Anything else?
No, that's fine.
Yeah.
I'm
So this is unique study in that some of them are, like association between A and B. What is the smoking and mortality rate? It's not simple. This is like, well, let's first see what kind of trend we see. So you're starting from scratch.
yeah.
And what can we learn more? What variables do we need to collect more? And what are the association we see? And then you come up with hypothesis. The reason we don't have recurrence rate here. We're looking at landscape, literally.
Okay.
Okay, so
Yeah.
if you don't find good, any good association to report, may not be worthwhile writing an abstract.
Oh.
We need to convincingly find a trend. But I think what you found, just like a one case, there was a post-surgical positive MRD that
Yeah.
was up by adjuvant chemo. I
Mhm.
think that's a really good case. That's even good for a case report.
Okay. Yeah.
So if you can find similar cases, where chemo didn't clear it, or it was always negative, and what is chemo doing if it's always negative? Why give chemo that can give you side effect when patient was already MRD negative? You can
Okay.
make a case for every, all the interesting discussion.
Okay.
And not only look at our own data, go and search what others have published in that exact question. What is the clearance rate of MRD with adjuvant chemo or immunotherapy?
Mm,
What is the clearance rate? Who knows? Has anyone looked at it? No. Then you might be the first one to look at it.
mhm. Yeah.
So it's the good question is everything. How do you come up with the good question? Think
Mm,
about that. No one is going to spoon feed you, okay? You
yeah.
own that. You own the question, okay?
Mhm.
Okay.
Thank you so much.
Okay. Okay, Eugene. Well, we'll talk. We're gonna talk after lunch. Okay.
Oh, sure. Okay.
We'll wrap up our, because I think we're
Okay.
the only one here. So we'll wrap
Yeah.
up. We're gonna have lunch first, take a break, and then talk about your project
Okay.
afterwards.
For sure.
Okay.
Thank you.